Hello everyone. In last video, we have discussed about distance time graph for car moving with uniform speed. In this video, we will discuss about non-uniform speed. So this is a tabular data of distance traveled by a car at a regular time interval. And that regular time interval we have taken as a 2 seconds. Every after 2 seconds, how much distance traveled by that car that we have noted. So this column represents the time in seconds and this column represents the distance corresponding to this time in meters. Now this graph, distance versus time graph, simply these values we have plotted. On x-axis there is time, or this is a time axis, and y-axis this is a distance. When time is 0, distance 0. When time 2 second, distance is 1 meter. 4 second, 4 meter, 6 second, 9 meter, 8 seconds, 15, 16 meters, 10 seconds, 25, 12, 36. So like that points we have plotted. And now if I connect those points, so what we will observe, this curve is not straight line. Obviously it is not a straight line, right? Because this curve is non-linear curve. Like in uniform speed, we have a straight line which is passing through the origin, right? There we were getting straight line which is passing through the origin, but here the curve passes through the origin, but it is curved or non-linear, we can say. Similar kind of graphs also. These are non-uniform graphs only, non-uniform motion they represents. These graphs also earlier in videos we have discussed what these graphs indicate. Again, distance versus time graph only both. But here this graph is increasing non-uniform motion and this is decreasing non-uniform motion. Simply, if I consider four time interval 1, 2, 3, 4, this time interval, the corresponding change in distance, corresponding change in distance or displacement if you take, then that displacement here it is increasing. Here it is in increasing order. And for every time interval, the corresponding change in displacement, if we compare that change in displacement with the other time interval change in displacement, so they are not equal. They are not same. Here from ds1 to ds4, the value or the magnitude, it is in increasing order. Similarly, here also the change in displacement corresponding to the time interval 1, 2, 3, 4, if you compare with each other, then it is not equal. Here, the change in displacement, the magnitude of it is decreasing. That's why we will call this graph as a decreasing non-uniform motion. So, corresponding speeds, we will say it is a non-uniform speed. The most important thing is in uniform speed, the curve or that line passes through origin and it is straight line. But here this curve is not straight line. Here it is curved or a non-linear shape. So nature of this graph is non-linear variation. Here the variation is non-linear. See, in uniform speed, there is distance and time. Direct proportion was there. So distance is directly proportional to time. Means as time was progressing, distance was increasing, right? But here similar kind of behavior, exactly similar kind of behavior is not there, right? So nature of this graph is non-linear. Shape of this graph is different compared to the uniform speed graph. Obvious. For the uniform speed graph, as I have discussed here, if you calculate the change in displacement ds value for every time interval 1, 2, 3, 4, for every time interval, the corresponding change in displacement ds value is same for all the intervals. For every interval, it is same, right? But in case of a non-uniform motion, this ds value, see here we have written 1, 2, 3, 4 because they are not equal. The intention behind giving the notation is these ds values or change in displacement value for those time intervals, they are not equal. Here the ds value is equal. So this is uniform motion and these all are non-uniform motion. So this is regarding with the distance time graph of a car moving with non-uniform speed. So here the speed with which car is going, we will say it is moving with a non-uniform speed. Thank you.